Okay, cool. So this is your question. So what you have really is n equal to CV. That is all good. So you remember to convert that thing there. So that is good there. But then your problem here is you don't know about the mole ratio. So you are saying that the mole of vanadium is the mole of SO2. That's what you're saying, right? So you get 0.04 and it's not really. So what can we say? So P equal to nRT is for the gas. So if that is true, okay, so let's see. You convert the kilopascal to Pascal, that is okay. This is 506 cm cube. So you know that 1 cm is 10 to the minus 2 meter. You could cube both sides. So you cube both sides and you get 1 cm cube, which is 10 to the minus 6 meter cube. So you got that correct. And R, and then 20.0 plus 273, that is fine. I assume your calculation is fine. If your calculation is fine, this should be okay. That is your mole of SO2. And there's 0.800 times 50, that should be all right as well. So now what you get is, we need to use changes in oxidation number to balance redox equations. I think I showed you this before. So you need to think about these changes in oxidation number must be balanced. In primary school, you call this lowest common multiple. So what do we have? We're gonna reduce the vanadium. This is VO3 minus because it's NH4 plus. If you look at the question, NH4 plus, VO3 minus. So if you look at VO3 minus, minus 1 equal to vanadium plus 3 times minus 2. Stop me if I'm going too fast, yeah? But you should be able to do all of this. Your question now is, what does the vanadium 5 plus go to? You don't know. It will be lower because we use SO2 as a reducing agent. We use SO2 as a reducing agent. Now there's some stuff you probably need to know. When the SO2 acts as oxidizing agent, what is it going to become when it acts as, reducing agent? So the question might ask you what is meant by a reducing agent. So your problem previously was about definition, right? So it reduces the other substance, but then itself get oxidized. Itself get oxidized. So typically we are thinking about SO2 going to SO3 or SO2 going to SO4 to minus, but we are not told what other information in this question. After the reduction is sulfur 4 oxide. I'm assuming since this is sulfur plus 4, I know it will go to sulfur plus 6. I just don't know whether it's SO3 or SO4 to minus. Because when SO3 dissolves in water, which you do have water at some point, because you have solution. If you look back at the question there, you have solution. Solution means you have water. So even if you produce SO3, which is a gas, it can dissolve in water to give you H2SO4. And H2SO4, you have 2 hydrogens, sulfur, 4 times minus 2 equal to 0. Overall oxidation number of the molecule is 0. So you know your sulfur turned out to be plus 6 as well. So in both of these, doesn't matter which one, you're always going to get sulfur plus 6. Are you with me so far?
Yeah.
Okay, so whether you get these or these, it will always be sulfur plus 6. You never see sulfur plus 5. The plus 4, acting as a reducing agent, itself must get oxidized. If itself get oxidized, you must become sulfur plus 6. All right. Now this is a change of plus 2. The change is plus 2. Okay. Now what do we know here? This is 0.02. If I approximate this, this is 0.02, right? If I approximate that, this is 0.04. So what do we notice so far? The mole of VO3 minus is to the mole of SO2. What was it? SO2 was 0.02, the other one was 0.04. Give or take, right? So that will be 2:1. So that means 1 of SO2 reacts with 2 of VO3 minus. Do you agree?
Yeah.
So that means if you think about it, I just think in your head, like logically, what does it mean? It means it reacts with 2 mole of NH4 plus VO3 minus, like that. Okay, but we know the sulfur must go to SO3. The sulfur must go to SO3. That is sulfur plus 6. So you have 1 mole of it. So if you have 1 mole of it, that means 1 time plus 2. Because you increase in oxidation number from sulfur plus 4 to sulfur plus 6, and you have 1 of it. Do you agree? Because you have 1 of it. Are you okay with this?
Yeah.
You sure or not? Okay, because I'm very worried, you know, when you say you're okay, but then I'm not sure you're okay or not. So there's 1 of it, and then this is plus 2 times 1. So meaning to say, if you think about the VO3 minus, this is vanadium plus 5, but then there is 2 of it. So 2 of it. So 2 in front, okay? And this must be 2 times the change. 2 times the change must be equal to minus 2. Do you know why it must be minus 2? Do you have any idea? Because 1 time plus 2 give you plus 2. And you have 1 of it, 1 of it, and 1 of it. The change in oxidation number must be balanced. You did LCM because when you do the change, which is plus 2 altogether, since you only have 1 of it, and they increase by plus 2, and there's only 1 of it according to your equation, total must be plus 2. So your opposite, which is your reduction, total must be minus 2. But then there are 2 of it because from your mole ratio, there are 2 of that VO3 minus. So there are 2 of it. 2 times the change must be minus 2. Follow so far?
Yeah.
Okay, so what is the change then? The change must be minus 1 because it's minus 2 divided by 2. So the change is just minus 1. So you started with vanadium plus 5. So that means the change will not be vanadium plus 3, it will be vanadium plus 4. Then we have 2 of it, so it's multiplied by 2. Does that make sense?
Yeah.
So therefore, it must be vanadium plus 4, the species, the final product. So it's a tricky kind of question. You might think that, you know, since this is 2:1, you might think that you must change by 2. But you know, when we do cross multiply with those crisscross of the formula, something like that, that is actually LCM. So you're going the opposite. How many mole do you need? How many mole do you need for each? And therefore, the changes there, it's like the opposite. So here you change 2, but here you change minus 1 because there are 2 of them. Okay, I hope that makes sense to you. What do they want actually? They just want the final oxidation state. They don't need the species. They don't need the species, they want the final oxidation state. Happy with that?
Yeah.